One of the kind of core principles of calculus that we've been talking about is changes, right? So derivatives are rates of change. Now we're going to talk about how we're going to accumulate change. So something is constantly changing, how much total change or how does that change add up? So jumping right into it here, if we start with area, let me change my color here. Okay, so area is what we're looking at. If a function describes a rate, so if I'm talking about how much something's changing, then the area represents the total change. So if a function is describing a rate of change, the area enclosed by that function represents the total change. For example, on a velocity function, the area describes the total change in position. And this is because the velocity function is describing the rate of change of position. So if I calculate the total area under that curve, it tells me the total change in position. Area is defined as between the y-axis and the, that is wrong, it's between the function and the x-axis. If it's below the x-axis, then the area is negative. And we can use geometry to find the area of, simple expressions. So this next example will kind of put that all into perspective. A snowstorm lasts 18 hours. The graph below shows the rate of snowfall. What is the total snowfall? So we're going to basically look at this graph and we're going to calculate the area under this curve. And we're just going to use geometry to do it. So if I look at this, I can break it up into a bunch of rectangles and triangles. And I know that's a little hard to see the yellow on here, but you can kind of imagine what that's going to look like yourself, how you break that up. So if you'll notice, we can kind of start to get an idea of why this works, because if we see the units up here of inches per hour and the units over here as hours, inches per hour times hours is going to give inches. So likewise, if I calculate area, that involves kind of multiplying these two sides together. So that first triangle is 1/2 times 2 hours times 1 inch per hour of the height, plus this middle rectangle, which is 2, 4, 6, 8, 10. 10 hours times an average, times a rate of 1 inch per hour. Then I'm going to do this top little triangle here, which is 1/2 an inch, so it's going to be 1/2 times 2 hours times 1/2 an inch per hour, plus this bottom rectangle here, which is 4 hours times 0.5 or 1/2 an inch per hour. And then finally 1/2 times 2 hours times 1/2. And that gives us 1/2 times 2 is 1 plus 10 plus 1/2 plus 2 plus 1/2, which is 10, 11, 13, 14. So 14 inches is the total amount of snowfall. Again, because the graph represents a rate of change, how much snow per hour, the area under that graph gives us the total change.